Hi, Trig and Pre-Calc, and welcome to your first foray into a flipped lesson. A flipped lesson is where you take notes at home and you do your homework at school. So I thought we would try this with this asynchronous day. Your mission today is to watch this video and to take notes over it, marking places where you might have a question or you didn't understand something I did. That way you'll come to school on Tuesday, right, because we have Monday off, and you will ask any questions. You've already seen the notes, and then we'll just start practicing. So I do like doing flip lessons, and we will do more of them as the semester progresses. So without further ado, someone's here. I'm going to hit pause. And through the magic of technology, you didn't even get to see that break I had helping a student. So we're back. We are getting ready to talk about Chapter 2. Chapter 2 is a specific type of function, a couple of them. It's called polynomials. And you may have seen it in Algebra 2, just like we did with functions. You'll need some reminders, but without further ado, let's talk about what a polynomial is and a couple of things that we're going to do with them today. So a polynomial, first of all, is a combination of variables, a single variable raised to powers. The powers cannot be negative. The powers cannot be fractions. So that's good news for some of us. No fractional exponents, no negative exponents, combined with different terms. What I have written right here is called a quintic polynomial. Quintic because it's to the fifth power. The biggest exponent you see is called the degree. And the very first coefficient that's connected with that term is called the leading coefficient. We can tell a lot from a polynomial just by its degree and by its leading coefficient. I have it written in standard form because it's in descending order of powers. Notice it goes from x to the fifth. The next smallest one, x squared, x to the first. There's actually an x to the 0 hanging outside here. Well, that's called standard form for a polynomial. So there you go. Remember polynomials now? Awesome. We're going to do some things with polynomials today. In fact, we're going to do 3 things with them. All of them deal with division. So here are the 3 things for these notes I want you guys to get out of this. 3 types of division. The first one is going to be a polynomial divided by a monomial. That's an easy one. The next one is a polynomial divided by another polynomial using long division. Oh my word. It's been a while, but hopefully you remember long division. If not, we're going to go over it. And then finally, a polynomial by a binomial, a specific type of polynomial where there's only 2 terms. And we're going to learn something called synthetic division. We are going to use long division and synthetic division in different parts of our semester. So you can kind of think of this as a prerequisite skill. But one that shows up in polynomials. So without further ado, let's start the first one, a polynomial divided by a monomial. I would like you to hit pause. I want you to hit pause and try this problem on your own. What can you do? What can you not do? Try to simplify this division problem. Notice it's a polynomial on top, divided by a monomial on bottom. It's a solo, it's one. Mono means one, a monocular. Omnocular? Wait, no, that's from Harry Potter, sorry. A monocle is what I was thinking of when it was just a single lens. Monomial, 1. Okay, we're back. Hopefully you hit pause and tried this on your own. When we add fractions together that have the same denominator, we simply add their numerators and put it over that same denominator. This is just going backwards. If I want to do this, I can write this as 3 separate fractions all over that same denominator. So it looks something like this. I can simplify this one to 8x squared. I can simplify this one to just 15 over 2. And I can simplify this one to 8 over 2x. Now notice, I divided these 2 things. Both of them were polynomials. But now I have something that is not a polynomial. You cannot have x's in the denominator. But that's okay. I didn't say you had to. We did the division. We simplified. We are dancing. That's it. All right. So a polynomial divided by a monomial. Piece of cake. Here's the next one. The next one is called using long division. It's been a while, but prepare to have your memories jogged for you. So long division, I'm dividing this polynomial divided by this little binomial, but also a polynomial. We have what's called the divisor and the dividend. What I'm dividing by is the divisor. What's inside the box, I'm taking this and I'm dividing it by x minus 2. What's inside there is called the dividend. And we set it up just like we did with long division. Now, something that's special with these, well, we're going to keep everything orderly and organized. Anything that has an x to the 3rd power will always be in the x to the 3rd power column. Anything that has an x squared will be in the x squared column. This is an x column. This is a constant column. So we'll keep things orderly and organized to help us throughout this process. So when you come to my class on Tuesday, there will be a bell work problem, and it will say use long division to divide. So we're going to have to remember how this went down, how this works. So I'm going to copy the problem down real quick. 6x cubed minus 19x squared plus 16x minus 4 divided by x minus 2. Okay? So how this works now. Instead of when it's with numbers, you just say, what is this divided by this? And we can write that number and go. It's actually, you have to work backwards and say, what would I multiply this by to get to this? And that's the same thing as division, but what would I multiply x by to get to 6x cubed? The answer? A 6x squared. And anything that has a squared on it goes in this squared column. So 6x squared. We put whatever I'd multiply this by to get to this first term goes up here. The next part of the algorithm, an algorithm is just a series of steps, is to take whatever we put up here and we are going to multiply it by both of these things or all of these things, whatever we're divided by, our divisor. So 6x squared times x becomes 6x cubed. And I put it down underneath all the cubes, right? Anything with an x cubed will be in this column. Anything with x squared in this column. So on and so forth. We do it again. 6x squared times a negative 2. That would be a negative 12x squared. The next thing I'm going to do is to change the signs on both of these. Change the signs on both of these. And add going down. Well, if you change the sign on something and add going down, you're really just subtracting. But students tend to lose negative signs and positive signs when that happens because you're subtracting a negative, things like that. So I prefer to change the signs on these. And now I'm going to add going down. Negative 19x squared plus 12x squared is a negative 7x squared. 6x cubed minus 6x cubed, or plus a negative 6x cubed. Those cancel, and we're left with negative 7x squared. Oh, you guys are leaving. It's Wednesday, and you guys are leaving. That's okay. The next part of the algorithm, we bring down the very next term. So the next term I bring down, and it's 16x. And the whole process starts over again. What do I multiply x by to get to negative 7x squared? The answer, negative 7x. So I'm going to put a negative 7x up here. And now I'm going to multiply whatever I put up here, negative 7x. I'm going to multiply by both of these and put underneath the next one. So let's see, that would be negative 7x squared. A negative 7x times a negative 2 is a positive 14x. I change the signs on both of them. Change the signs on both of them. And I add going down. If I add those, they give me 0. 16x's plus negative 14x's are 2x's. Bring down the next one. One more time with it. What do I multiply by? A positive 2. Positive 2 times x, 2x. Positive 2 times negative 2, negative 4. We change the signs on these, and we add going down. In this case, when there's nothing else to bring down, this would be my remainder, but there is no remainder. Hooray! Pausing it. I'll be back. Okay, I've changed course. We are only going to do one more problem and then be done. I'm not going to do all the notes. We will have to finish the notes on Tuesday, but let's finish this. So on that last one you saw, there was no remainder. That means that divisor fit into the dividend perfectly. Well, that doesn't always happen. So here's an example for this one. I'm going to divide x to the fourth minus 3x squared minus 1 over divide by x squared plus 5. Now, one thing you need to notice here, remember when we did the long division thing, I kept all my exponents in the same columns. I organized them. That means when we're missing some, we need placeholders. I'm going to need a 0x cubed in here. I'm going to need a 0x in here. And I'll be right back. So we're missing, so I need a 0x cubed. I'm also missing a 0x to the first. We need placeholders for all those things, not only in the dividend, but also the divisor. We have to have zeros in there for any missing exponents as we go down 4, 3, 2, 1, 0, 2, 1, 0. So this problem that I just wrote in purple, when we're doing long division, actually looks like this. Let's see if we can show both of them. Okay. Take a minute, if you haven't already, hit pause and see if you remember those steps to long division. Go through, try it out. Okay, we're back. I think we're back. I don't know. Here's how it goes down. What do I multiply x squared by to get to x to the fourth? The answer is x squared. So I put an x squared up there. Notice I keep it in the x squared column. Next, I multiply x squared times all three of these, and put it where they belong down there. So x squared times x squared, x to the fourth. X squared times 0x, that's 0x to the third. X squared times 5, that's 5x squared. Now we change the signs on all of them. Minus, minus, minus. And we add going down. These will give me 0. These will give me 0. These will give me, not 0, negative 8x squared. Negative 3x squared plus negative 5x squared, negative 8x squared. Next we bring down the next one. But what I want you to notice, since there are 3 terms in the divisor here, I need 3 terms in my dividend. So I'm not only going to bring down one, I'm going to bring down another to make this happen. And then it all starts over again. What do I multiply x squared by to get to negative 8x squared? Answer, negative 8. Put a negative 8 in there. I'll multiply negative 8 times all 3 of these. Zero x. Negative 8 times 0x is 0x. Negative 8 times 5, negative 40. Next, change signs. Change sign, change sign, change sign. Add going straight down, those cancel. 0 plus 0 is 0. That will give me a positive 39. Now notice, there's nothing left here for me to bring down. So what is left is my remainder. And how we write our remainders in these, we add our remainder onto the outside of whatever our quotient is, our answer. So I'm going to add 39. But what was I originally dividing by? It's not just 39. We've already handled the constant. This isn't a constant. This is a remainder. So it's 39 over what I originally was dividing by, which is x squared plus 5. Okay, that's it. Everything up here is our final answer. X squared minus 8 plus 39 over x squared plus 5. That is all we're going to do right now. What I want from you guys then, we're not going to do all of the notes. I want you to do part of your stamp today. Okay? Not going to be due until the Wednesday we get back, but you can at least get started on it now. Page 239. I want you to do 7 through 15 odd. Give them some good effort. Bring your questions with you on Tuesday. I look forward to your arrival. Have a good rest of your break. Peace.